Okay, so those are some of the questions that we just need to look at. Um, I think with what I've done so far, there's no need for, let me just treat one again. Now look at if 3p minus q equals to 6, and then 2p plus 3q equals to 4. So you can say find the value of p and q. So if you are looking for, I hope you can hear me. If you cannot hear me, let me know. So okay, all right. So to solve now, if you look at this one, the second one, what we just do there is that you can try to make either p or q the Pareto formula. But if you look at it, it is very easy for us to make q the Pareto formula here. So making q the Pareto formula here, it means that what? You take that, because it is minus q, so take it to the other side, so that you have what? You have q, then 6 here, we come to this side, so it becomes what? 3p minus 6 is equals to q. So it means if you need to replace that what? That q, you use what? 3p minus 6 to replace it. Is that clear? So if I need to go to the second equation now, I can always use what? Q equals to 3p minus 6 to represent it. So how do I go about it? So meaning that anywhere I see Q there, I represent it with 3p minus 6. So there I have what? 2p. I have 2p plus 3q, meaning plus 3 times 3p minus 6 will be equals to 4. So with that one now, so that will be what? This will be times. So it means that will be 2p plus 3 times 3, that will be 9. So 2p plus 9p minus 18 equals to 4. So minus 18 will go to the other side. It becomes 4 plus 18, and that will give us 22. So from there, we can say that we have what? We have the 11p equals to 22. 11p equals to 22. So meaning that our p equals to 2. So if p is equals to 2, it's very easy for us to find the value of what? Q. Just come back here and substitute. Come back here and substitute. So anywhere you see, if you are looking for Q, Q will now be equal to 3 times 2 minus 6. So that is solution to that particular one. So um I don't think I will do any other one there again. So yes, there's a question here. Can anybody try this in maybe a few seconds, 10 seconds? Is it possible in 10 seconds? Solve the equation. What's the value of x? What's the value of y? You can solve it. Maybe I may even give you time to maybe share what you have with us, if it is possible. So let me use that to give us a break of 3 to 5 minutes. So uh, Is Q equal to 0 in that question? Okay, yeah, 3p minus 6. Yeah. Okay, yeah, I understand. The other one. Well done. So I'm expecting your, that's why I'm stopping here. I'm expecting your response. Once you are done with your answer, you can try to just signify so that I can allow you to talk, to share the way you have done it. So if you are true, let me know. You have just a few minutes for that. You have about 3 minutes more. I'm yet to see anybody. Okay, let me unmute you to hear from you before. What's the challenge with the question? Any challenge there? Any challenge there?
So yes.
What's the problem?
So The second one is x square minus 4y square equals to minus 16. Is that
Okay.
not is that not difference of 2 square?
All right. You can try that.
Okay, okay.
So anybody with anything? So nothing yet. Okay. I think the person that has the question now should be able to. Have you got anything now? Okay, Umar Esther. Umar Esther, you can unmute yourself and talk. Okay. Somebody has said y equals to minus 2. Okay, if y equals to minus 2, s equals to 4, y equals to minus 2, s equals to 4. Okay. Okay, so can you share what you have done with us? Ify, can you share your screen? Should I allow you to share your screen for us to see how you have done it? Okay, you are on. Okay, Ablaziz Farida, you have y equals to minus 1 and x equals to minus 10. Okay, somebody said I got plus 8, not minus 8. Okay, so who is ready to share? All right, our time is fast spent. I think we can try to continue. I want you to share your screen here so that we can all learn from ourselves. It's a nice idea that we also try to learn one or two things from ourselves. Okay, notwithstanding, let me just move on. Let me explain. Now, like somebody said the other time, that difference of two squares, if you look at this truly, if you look at this truly, is a difference of two squares. So just leave equation one. Equation one is okay. So, but let's go to equation two. If you look at that, you realize that we have difference of two squares. So for the difference of two squares, how do we do it? So if you need to do that, we have s squared. I can rewrite that one to be minus 2y everything squared is equals to minus 16. So from that, when you have difference of two squares, how do we do it? If you have a squared minus b squared, you know it's same thing as what? A minus b, a plus b. Please, you writing, please respect yourself. So difference of two squares, difference of two squares. So that is what we have tried to write there. Difference of two squares. So for that, so it means for this one now, I can have it as x minus 2y, x plus 2y equals to 16. That's minus 16. That's minus 16. So, so minus 16. So in that case now, but you know that in equation one is x minus 2y, which is same thing as what I have here. So I need to replace x minus 2y I have here with the answer in equation one, which is minus 8. So I'm going to have what? Minus 8 x plus 2y equals to minus 16. So if you divide both sides by minus 16, minus 8, divide both sides by minus 8. So it means I'm going to have what? X plus 2y equals to 2. So you can see the two equations I have now. So I can say that I have equation 1. This equation 1 is still equation 1. Then I have another one, equation 3. So, so I can say that I have x minus 2y equals to minus 8. I have x plus 2y equals to 2. So these are the two major equations I have now. Now I can apply my elimination method. Elimination method of simultaneous equation. It says that when you have you try to make uh, the coefficient in both equations, try to make them to be what? To be equal. So look at this one now, minus 2y plus 2y. So if I add the two equations together, x plus x will give me what? 2x. Minus 2y plus 2y will give me 0, is equals to minus 8 plus 2. Minus 8 plus 2 is minus 6. So if you divide both sides by what? 2, I have my x is equals to what? Minus 3. So if x equals to minus 3, what is my y? So I will go and substitute this into equation 1. So if I substitute into equation 1, in equation 1 I have what? So let me see what I can clean here. So if I substitute in that above now, so minus 3. So I'm going to have minus 3. I'm going to have minus 3. So minus 2y. I don't know that. Minus 2y equals to minus 8. So with that, I have what? Minus 2y. Minus 3 will go that place to become what? Plus minus 8 plus 3. That's minus 5. So divide both sides minus 2. My y will be equals to minus 5 over minus 2. Minus 5 over minus 2. So it means my y is what? 2.5, 2.5. And my x is what? Minus 3. I believe that you understand this clearly. So you can see the trick that we use to solve it. So just the trick of difference of two squares. So it means our x equals to minus 3, y equals to what? That's 2.5. So that's the solution to that particular one. I want to believe that there's no problem. Uh, Maybe we have to jump. So, so the next, okay. So quadratic equation is the next thing that let's just, I think immediately after this quadratic equation, then we move to the main indices, the main topic of today. So we also have, when we talk about quadratic equation, is also an aspect that we also need to look at. In quadratic equation, what we actually have there in quadratic equation is we have equation of the form y equals to ax squared plus bx plus c. That is what we mean by quadratic equation, where a, b, and c are constant, and a must not also be equal to 0. By the time a equals to 0, you realize that the term in s squared will cancel out, and as a result, we are going to have maybe y equals to bx plus c, and that is a linear equation. So b can actually be equals to 0, c can also be equals to 0. A quadratic equation can be of the form y equals to 4x squared. Y equals to 4x squared is a quadratic equation. What we are after there is that the term in s squared must exist. So the term in s squared must exist. That is just what we mean by quadratic equation or quadratic expression. So I have some questions here for us to quickly go through. X squared plus 5x plus 6 equals to 0. X squared minus 5x plus 6 equals to 0. X squared minus 5x minus 6 equal to 0. X squared plus 5x minus 6. You can see, so that's why the sign is very, very important. You can see that I just try to alternate the sign. Those are the 4 different cases. Number 1 to 4 are just 4 different cases that you can have. You can have your b to be negative, you can have your, so that's just the way I've listed it. So the major thing that you need to look at here is to multiply the term in s squared, the coefficient of s squared, by the constant, the one without x. Multiply them. In the case of equation 1, we have 1 to be the coefficient of s squared. There's nothing there. It means the coefficient is 1 multiplied by 6. So it means we have 6. Then you look for the factors. You look for the factors of 6. What are the factors of 6? 1 times 6 will give us 6. 2 times 3 will give us 6. There's no other option again. So from from those things that we have listed, which one will give us, when we add them together, will give us 5? If you look at it, we have plus 6. There's also something that we also need to know. If you have forgotten before, you have been taught. That's a sign multiplication. If you have plus times plus, it will give us plus. Then minus times minus will also give us what? Plus. That is, when you have same sign, it becomes what? Plus. But when you have different sign, minus times plus, it will give us minus. And plus times minus will also give us what? Minus. So you can see, so that's very, very important in our quadratic equation. So what sign and what sign are we multiplying? We are multiplying plus 1 and plus 6 to give us plus 6. So the two things that we need to look at, two numbers to multiply together, they must also be plus plus or minus minus, so that to be able to achieve the plus product. So in this case, I said we have 1 times 6 and we have what? 2 times 3. Or either plus plus or minus minus. So both of them work. But which one, when you add them together, will give you 5? So if you see, look at this one, you realize that when you add this one together, it will give us what? It will give us 7. But when you add this one together, it will give us 5. So that is the replacement that you are going to use. So instead of having this 5x, instead of having that 5x, it means you are going to have what? 2x plus 3x to make up that 5. 2x plus 3x. Because the major thing we look out for in quadratic equation is the fact that we want to factorize, but we have just 3 terms there. So you can't group them into 2 like this. So you need to look at those ones at the middle. Those ones at the middle. How do we split them so that the number of terms will become 4? So that's our aim. So it means we replace that one with 2 plus 3x. So if you have that now, it means we are going to have what? S squared plus 2x plus 3x is equals plus 6 equals to 0. So with that you have, you can now see that this and this, they form a group. This and this form a group. So what are those things common uh, between them? The first one, x is common between x squared and 2x. So bring that x out, plus, bring that x out, then we have into bracket x plus 2. The other one, 3 is common there, plus 3. Bring it out, x. When you divide 6 by 3, you are left with 2 equals to 0. So from there, you can see that x plus 2 is common. So bring out the x plus 2 that is common. What do you have left? You have x plus 3 left. X plus 3 equals to 0. So as a result, if you do what you are supposed to do there, x plus 2 equals to 0 or x plus 3 equals to 0. So we are going to have x equals to minus 2 or x equals to what? Minus 3. Because you have been able to see that x plus 2 equals to 0. That's a linear equation which you must be able to solve. X plus 3 equals to 0. That's a linear equation which you must be able to. So x will be equals to minus 2 or minus 3. So that's the solution to that particular question. So I will try to look at the last question too. I will try to look at the last question too before we move to the major topic of today. So if you look at the last question, we have 3x squared minus 4x minus 4 equals to 0. So apply the rule is that you multiply the coefficient of s squared by the constant. So the coefficient of s squared here is what? Yes, minus 3. Coefficient of x here, s squared here is minus 3. So, and the constant is what? Minus 4. So if you multiply, you have minus 12. When you multiply that, you have a minus 12. So it means that what? What are the factors of minus 12? So list them out. We have 1 times 12. We have what? 2 times 6. We have what again? We have 3 times 4. All this, we can combine them to get what? To get the factors of 12. So, but which one? In this case now, we have minus 12. Like what I illustrated the other time. We must have different signs, 2 different signs to be able to have a negative. So in that case now, for us to have a negative sign, so we must have either minus 1 plus 12 or minus 6, minus 2 plus 6, minus 3 plus 4, in that manner, or you interchange it. So if you look at everything I've written now, which one will produce minus 4 that we have here? Which one will produce minus 4? You know we have minus 4x. So we want to replace minus 4x. So if you look at the first one, minus 1 plus 12 will give us 11. minus 2 plus 6 will give us 4. Oh, but we are looking for minus 4. So since you have got 4, what you just need to do there is what? Swap that sign. Swap. So it means we are going to have what? Plus 2 minus 6. Instead, you have plus 2 minus 6. So it means plus 2 minus 6 we replace what? So it means we are going for this. But you interchange the sign. You realize that the last one 2 cannot give us. Minus 3 plus 4 will give us plus 1. It's not. So you replace. So I'm going to have what? 3x squared. Instead of having minus 4. Instead of having minus 4, I'm going to have what? Minus 6. I'm going to have minus 6 plus 2. Or 2 minus 6, whichever one. So minus 6x plus 2x minus 4 equals to 0. So in this case now, we realize that what? This and this, what is common? 3 is common. This and this, what's common? 2. So bring them out. So 3x is common into brackets. We have 2x left. We have 2x left. Sorry, x. We have x left. So we have x minus 2. In that case, 2 is common. 2 into brackets x minus 2 equals to 0. So from there, you can see that x minus 2 is common. X minus 2 is common. Bring it out, x minus 2. Then you are left with what? 3x plus 2. 3x plus 2 equals to 0. So from there, you can equate all those things that you have there. So if x minus 2 equals to 0, it means s is equals to 2. Then the remaining one, if 3x plus 2 equals to 0, you take plus 2 to the other side, becomes minus 2. So it means we have what? X equals to minus 2 over 3. So x equals to 2 or minus 2 over 3. So that's the solution of that particular question. So based on that, we need to move fast. So let me just take us through the indices, the main thing that we want to now look at. So at least with this now, we are good to go to any question on indices. So don't forget, when we talk about indices, what we actually mean is that what we have a raised power m, and it's the m represent the power on the index, the a is the base. So 2 raised power 5 is same thing as 2 times 2 times 2 times 2 times 2 in 5 places like that. So don't be very careful. Don't tell us that 2 raised power 5 is 2 times 5. No. 3 raised power 4 is not 3 times 4. No. It is 3 times 3 times 3 times 3. Then likewise, 1 over 4 raised power 3 means 1 over 4 times 1 over 4 times 1 over 4. So in the number of times indicated in the power. So having known that, we have product law. A raised power m times a raised power n to give us a raised power m plus n. So product. So when you have the same base, when you have the same base like that, you multiply, you just take a common base and add the powers. That's what you have seen here. You can see 2 raised power 5 times 2 raised power 3. 2 raised power 5 times 2 raised power 3. In that case, we have what? We have 2 raised power 5 plus 3. So that's just the simple law that we can look at in that particular one. If you look at so if you look at the next question, we also said the next one we have division rule. So for the division rule, we have a raised by m divided by. So in the case of divided by, you have that. Okay, not clear enough. What is not clear? Can you unmute yourself to talk? Somebody said it's not clear. Okay, that was before. Okay. All right. Thank you very much. Okay, Zainab. Okay. All right. No problem. I think I can proceed. We're almost rounding up the class. So now look at the question. Look at what I have on the board on my screen. So I also have 7 raised power 3 over 5. I know that fraction is usually a problem. So in this case, 7 is common. Then 3 over 5 minus 1 over 2. So by the time you do that, the SCM is 10. So 10 divided by uh, and so like that. What part of the logic you can just use here is that you can use the denominator here to multiply the numerator up here. 2 times 3, 5 times 1. 3 times 2 will give us 6. So to make 6 up here. 5 times 1, 5. So 6 minus 5. But the what you must have as denominator must be product. So 5 times 2. So that is that. Then we have a question here. 8 raised to power what? N times 2 raised power 2n divided by 4 raised power 3n. So what you just have to do here is that you can see they are not in the same base, but they can be made to be in the same base. 8 is the same thing as 2 raised power 3. 4 is the same thing as 2 raised power 2. So we have 2 raised power 3n times 2 raised power 2n divided by 2 raised power 2 times 3n. And that will give us 6. So you have 2 raised power 3n plus 2n. Then because we have division here, it becomes minus 6n. So you at the end of the day, you get what? 2 raised power minus n for that one. The next one, other laws that we have. So those other laws that we have, I just try to look at everything in totality. So we have a raised power m also raised power n. So you multiply. If you have n truth of a raised power m, it becomes a raised power m over n. You can also reverse that. If you look at what you have in this case now, if you look at here, sometimes you may be given a raised power m over n. So it means that the m will still be the power, you can see. But the n will be what? The root. So you can see n truth. So the denominator will always be the root. So we have question C here too. A raised power minus m is same thing as what? 1 over a raised power m. So another way this one we can also imply this is if you have a fraction a over b raised power m, which is equals to what? What you just need to do, you don't need to do 1 over again. You don't need to say 1 over a over b. No, don't complicate issue. So what you can just do there is what? A over b raised power minus m. Turn that whatever you have at the base, turn it upside down. So it becomes what? B over a raised power m. As simple as that. Then likewise for d, a raised power 0 is equals to 1. Then for e, a raised power m times b raised power m equals to what? So, so in this case now, for I have a question here. That's the third root of 8 over 27 minus 4 over 9 raised power minus half. So you can see this. How do you do it? So the third root of 8 over m, we have said that anytime you see the 3 here, okay, it's third root. So it's very simple here because you just need third root of 8 is 2. Third root of 27 is 3 minus. Now, okay, look at the rule that we said here. That anytime you have minus, to remove the minus, you turn whatever you have upside down. So if you turn 4 over 9 upside down, I'm going to have what? 9 over 4. That's why I have 9 over 4 here. 9 over 4 raised power half. So 9 over 4 raised power half is equals to, okay, so in that case, I still have 2 over 3. Then, so like we said in that room, this one, this half there, 2 that is down means square root. So square root of 9 is 3, square root of 4 is 2. Then you can find your LCM. And then another thing, like I said the other time, another thing you can just do here, another trick here is just to multiply the 3 down by the 2 down. 3 times 2, 6. Then use 2 to multiply the 2 here as if it is diagonal. 2 times 2, 4, minus 3 times 3, 9. So 4 minus 9, that's minus 5 over 6. So that is the solution to that particular one. So those are some of the questions on the indicial expression. But if you move to uh, forms of indicial equation, so we have these forms. But I think time is on our side. It's not on our side. We should be rounding up now. So this should be the last slide. We are supposed to go through all this. Once you can solve all the questions on the screen, it means you don't have any other problem in indices. You don't have any other problem in indices. Once you can solve all these questions here. So, but let me just give us the clue. Look at the first one, 4 raised by x. This is indicial equation. Some people call it exponential equation. So, how do we, okay, so for this particular case now, is it this one that x equals to 3? Okay, yeah, okay. So if you look at this, the first one, 4 raised by x equals to 8. What you just have to do here, anytime you have equation like this, they want us to compare. We can make comparison. The case of question 1, question 2, up to question 4, they just want us to make comparison there. So that is what they need from us. Make comparison. So once you make the comparison, okay, once you make the comparison, it's Ify, it's only Ify that is very active in this class. So if you make comparison, it means that we have, so that's just the major thing there. You try to make comparison. So when you make comparison, 4 is per x, okay? So, okay, yes, Farida, yes, 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 I can see, yes. So, in this case now, for me, sorry. So if you make comparison, now, you just make sure that what, the, you make sure that they have both the same base. They all have the same base. So once you do that, so I just came in. Can you please explain number 1? Okay, I will explain. I will explain. I will explain. So for the number 1, like I said, you make sure that what, you have the same base. Now, if you look at 4 here, it's 4 is okay, but it's not easy for you to make to write 8 in terms of base 4. It's not easy. So what you just do is that you reduce both. 4 is same thing as 2 raised power 2. Then x is there, which is equals to what? The 8 is same thing as 2 raised to power 3. How do you know that 8 will give us 2 raised to power 3? Another way of doing that is just to come to something of this nature, put 8 there, and continue to divide. 2 can divide 8. If 2 divide 8, it will give us 4. 2 again divide 4, it will give us 2. 2 again divide 2, it will give us 1. So how many 2 have you been able to use there? You have been able to use what? Uh, 3 different 2. So 2 times 2 times 2 times. So that's why we have 2 raised power 3. So since you have been able to express them in the same base, so it's very easy for you to compare. So you can just say that the 2 here, forget the 2 out. So it means the power, if the base are equal, the powers too must be equal. So you can say that 2x is equals to 3 and x is equals to what? 3 over 2. So that's the, which is same thing as what? 1.5, 1 over 1 over 2. So that is that one. Okay. So the next question. Okay, s equals to 5 over 3. Okay. So the next one, how do you do the next question? The next question is x raised power 3 equals to 64. So what you can just try to do there is what? The 64. Can you break 64 down? If I need to break 64 down, what do I have? Number 4, 8x equals to 40x raised power minus half. So in this case now, okay, so in this case for the question number 2, I'm going to have what? I have x. So can you break 64 down? I have 64. I have 2. 2 in 64, 32. 2 in 32, 16. I'm coming 2 in 16, 8. 2 in 8, 4. 2 in 4, 2. 2 in 2, 1. So if you look at that, you realize that we have got 2 in how many places? 1, 2, 3, 4, 5, 6. Okay, I think somebody was trying to raise his hand and he has dropped back. Okay, so it means it is 2 raised power what? 2 raised power 6. So I can easily come back here and say that what? I have x raised power 3 equals to what? 2 raised to power 6. So x raised power 3 equals to 2 raised power 6. So in that case, what do we now do? I have x raised power 2, x raised power 3 equals to 2 raised power 6. So another thing is that this 3 here, how do we make it to become 1? Because we are looking for x, but we have 3 there. So you can just take that 3. 3 is same thing as 3 over 1. So bring it outside. Esther, any problem? You can unmute yourself and talk if you have something to say. Uma or Esther, you are free to unmute. Okay, I will assume that you don't have anything to say. So if you have something to say, you can just unmute yourself and talk. Okay, let me continue. We have limited time. Okay, so it's like 3 over 1. If you turn 3 over 1 upside down, it becomes 1 over 3. You now come up, say multiply both the power by 1 over 3. Multiply by 1 over 3. So by the time you multiply this one by 1 over 3, the 3 will cancel the 3. So you are left with just 1. The 3 here will also cancel 6. You are left with 2. So 6 raised power. So that one becomes 2 raised power 2. So it means we are going to have what? X raised power 1. This one will become x raised power 1 equals to what? 2 raised to power 2. So meaning that x is equals to 4. So that's the solution to that. So that's what you are going to do. You just look at what you have at the power. What do you have at the power? Okay, yes, yes. We can also have it like that too. So like if you said, we can also have it like Yes, you are right. So we can also have it as x raised power 3 is equal to 4 raised power 3. Yeah. So the next question, number 3. Quickly, what you do in that case. You see what you have in number 3, you have x raised power 2 over 3 equals to 64. If you break 64 down, you also realize is that it is what? It is 2 raised power 6, like we said the other time. So we have what? X raised to power, you have x raised to power 2 over 3 equals to 2 raised to power 6, like we did the other time. So in that case now, the power we have here is 2 over 3. How do you make it to become 1? When you want to make it to become 1, you just bring that 2 over 3, turn it upside down, it becomes 3 over 2. So multiply both powers by what? 3 over 2. So if I multiply this one by 3 over 2, I will also multiply this one by 3 over 2, the power here. So with that, I'm going to, for the x will become x raised power 1. For the second one here, 2 will cancel the 6, it becomes 3. So that will be 2 raised to power 3 times 3, that's 9. So it means our x for number 3 is what? X equal to 2 raised to power 9. For number 4, how do you solve something of that nature? What you just need to do in number 4 is similar to what we did in one of those questions where they say find the value of x over y. What you just have to do here is to make sure that both x and y, they are what? They are in the same place. They are in the same what? They are in the same place. So you can divide both sides by, if you divide both sides by, make sure that you just have, they are on the same. How do we do that? So you have 8x equals to 40x raised power minus half. So for me to get, what I just do is what? I can just say divide both sides by what? X raised power half minus half. I want the x raised power minus half to come to this side. Divide this one by x raised power minus half. Divide this one by x raised power minus half. So it means all my x will be on the same place. So all my x will be in the same place. Then I also need all my number to be in the same place. Divide both sides by 8. So with that, all my numbers are also in the same, because this 8 here, we cancel this 8 here. So it means I have x raised power 1 divided by x raised power minus half. By rule of indices, it becomes x raised power 1 plus half. So, and which will give us what? 40 divided by 8 is 5. So that will be x raised power 3 over 2. X raised power 3 over 2. X raised power 3 over 2 is equals to 5. So you can complete that. It means you turn 3 over 2 upside down, it becomes 2 over 3. So our answer will later become 5 raised power 2 over 3. 5 raised power 2 over 3. So that is that one. Now for question number 5. What you just need to do there is, it's like we have a radical there. There's no way you want, there's no rule that talks about addition or subtraction. So in that case, what we are going to do in is like represent 2 raised power y by something. Represent it with something so that we can say that we have 2 raised power 2y times 2 raised power 1 so times 2 raised power. So that is what we are going to do, times 2 raised to power 1. You know what we have now, what I have done now is still the same thing. It's still the same thing as what we have there. So I will just have it like this so that I can break it down. Then the other one I have minus 15 2 raised power y minus 8 equals to 0. So anywhere you see 2 raised power y, you can represent it with something. So how do we do that? You can see this one here. We can still rewrite it as 2 raised to power y also raised power 2 times 2 minus 15 2 raised to power y minus what? Minus 8 equals to 0. So anywhere you see 2 raised power, we can put p there. So I have p squared times 2 minus what? 15p minus 8 equals to 0. So you can see this is same thing as 2p squared minus what? 15p minus 8 equals to 0. How do you solve this? Don't forget, if you want to solve this now, you can multiply 2 times minus 8.
That's minus 16. Minus 16.
So if you multiply it, will give you minus 16. So what are the factors? What do we use? What do we use? Minus 16 plus 1, Abby. To change this with what we have done before, minus 15 plus. So based on that, you are going to have what? 2p squared minus what? 16p plus p minus 8 equals to 0. So it means if you do that, we have p minus 8 and then 2p minus that's 2p minus 4. So can we do that now? So what will it give us? Okay, 2p minus, okay. So you can see that 2p is common here. So we bring out 2p into bracket p minus what? Minus 8. So at the end of the day, you are going to have uh, so you have 2p plus 1 equals to 0 and p minus 8 equals to 0. So our p equals to 8 or minus half. P equals to 8 or minus half. So if p is equals to the issue there is that p equals to that 8 will not will only work, but p equals to minus half will not work because you have to go back to replace this. So when you are replacing, don't forget you are 2y is represent p is representing 2y. So you just say 2 raised power y equals to p, and p is 8. So it means 2 raised power y equals to 2 raised power 3. So it means y is equals to what? 3 will be the answer. For the second value, because it is negative, there's no way you want to represent square of a number. So as a result, our answer is y is equals to 3. Y equals to 3 is the final answer. You are going to, the second one does not have solution because of the minus. There's no way we want to express minus as a power. So that's why we are going to leave it like that. So the last one, let me just take us to the last one. Anybody with idea on what we can do for the last question? So our time is fast spent. But let me just let me share so that to have access to some of the, I'm going to send this particular slide. I'm going to send this slide But what happened is that let me send I've tried to create a particular group where you can at least where we can interact. So let me send you the link to, I will send the link to the group here so that you can all join that group. So if you have any question, you can raise up your hand so that we address that. So you can find the link at the chat room. Okay, let me send it to everyone. So I've sent the link there so that you can join that particular one. For what you do, let me give you the clue to the last question. So maybe when you have done, you can just send me the question. So you can see the chat there. In the chat, you can see the group there, so you can join. So what you just do there is that you can see that 1 over 3 is common. X raised power 1 over 3, you can see that x raised power 1 over 3 squared minus 5 x raised power 1 over 3 plus 6 equal to 0. So use that x raised power 1 over 3, use something to depict it. Maybe p. So maybe p, so it will be p squared minus 5p plus 6. So you can do it through that means. So I think this is where we are going to stop the class today. So for next week, we are going to look at logarithm, all areas of logarithm. There are still so many questions in indices that we still want to consider. So, uh, so if there's any problem, you can always contact me. So we shall solve any problem that arise. So you can always join the class. So you can join the group if there is any. Any question? Okay, what? Yes. If you can use Godman, actually I'm going to send some questions to you through the chat. Somebody said what textbook? Part of the textbook that you can make use of, you can make use of Godman, you can make use of projects, further mathematics projects. So those are the two major, there are also some other ones. So then through the group, I will also send this particular notes to you so that you can also use it to revise. Then likewise, I will send some other questions that we can also use to revise. You know, it should be more than these 2 hours we are using here. So after this time, go and practice. So the more you practice, the better you become. Thank you very much for being part of the class. I appreciate your presence and your cooperation. So see you next week. Have a nice time. Thank you very much.